Now, a completely different point of view here, and I'm really, really pleased. Just I'm taking my time so I can clear the stage, because I've seen a number of Matt's presentations, and he likes to walk around, so that's why I wanted to make sure we were nice and clear. But I'd like to introduce Matthew Griffin. He's a futurist, the founder and CEO of the 311 Institute, an exponential university, and I'm really keen to sort of get an idea from probably a little bit of an external perspective on what aviation could look like in the future. So, Matt, where are you? Here we go. Brilliant. Welcome, Matt.
I'm over here. Thank you. Right. Good to see you. Yeah, thank you, Mark. As Mark kind of says, I am kind of the outlier. I sort of am not. Now, so firstly, thank you to IATA for inviting me to be on the stage so that I can keep you from dinner and dancing in Hanoi later today. And I do realize I'm the penultimate. Now, when we actually have a look at what I do, I look at the next 50 years of technology and trends. And while I'm an outlier, I actually work, for example, with the US government on the $1 trillion future of infrastructure bill. So I have quite a lot of different perspectives. I work with airlines, operators, I work with governments, and I work with regulators around the world to try to see what the future of aviation could look like, why it might look like that, but actually how it fits into the overall other mix of mobility and other industries and so on and so forth. And recently I was over in Louisiana, and some of the things that we started talking about, we were talking about the future of transportation within Louisiana in the year 2055, because we're trying to develop the vision and the strategy for different states within the United States. And we're talking about all these different modalities that we have, self-driving cars, electric vehicles, and so on and so forth. But actually, when we started extending out to about the year 2045, increasingly, we were talking more in terms of things that fly. So not necessarily UATs and UAMs, flying cars, and so on and so forth. But we were talking about that because the state legislature was saying, what does the future of our transportation system look like when a third of New Orleans is underwater? And we see the same in Miami as well and everything else. We have about 54 global megacities today, and beyond 2050, increasingly more of them will be suffering from sea level rise and everything else, which fundamentally changes where you might build an airport, how you lay out your multimodal transportation strategy, and so on and so forth. Now, in this particular presentation, I'm going to be looking at the future of aviation safety, efficiency, and sustainability. Now, from safety perspective, I love the aviation industry. I am very confident I can get into a plane anywhere really in the world, and I can get off it nice and safely the other side. When we talk about efficiency, I think I'm spending more time seeing canceled flights. So again, especially in the US, as Tim kind of alluded to, we saw cancellations because of bad weather in Philadelphia, Atlanta, New York, and everything else when I was in Florida and Miami. But also, when we have a look at sustainability as well, I tend to get hit around the head a little bit. That's it, because this year alone, I've been in 60 different countries. This week, I'll do about 20,000 miles. Next week, I'm going to be doing about another 15,000 miles. And I'm thinking about getting my pilot license. Well, I'd probably be rubbish at it. Now, where's the thing? There we go. So I've kind of put this agenda together for you. So future foundations, and then we're going to be having a look at efficient, safe, and sustainable aviation. Now, some of these things you will know already, but what I want to do is I want to show you some things that you perhaps don't know, and that you haven't seen, and that you haven't thought of when we talk about the future of these different topics. Now, we all know that we live in this kind of VUCA world, volatile, uncertain, complex, and ambiguous. But increasingly, especially in the United States, we're adding the word max to it. And the reason for that is because increasingly a lot of the changes that we're seeing in the world are massive. They are systemic, on system level changes. geopolitics, technology, environment, economic, and so on and so forth, societal. These changes are accelerating. And this is putting a lot of you under pressure, because if you step back 1, 2, 3, 4 decades ago, when you were planning out the future of the industry, it looked a little bit linear. Whereas now, as we've heard from other speakers on the stage today, we are now trying to integrate space and drones and UATs and UAMs and all kinds of other things. And then exponential, because increasingly the technologies are letting you do new things, and tomorrow's technologies are not necessarily the same as today's. And we've seen a lot of technological change. Now, to try to put this into context, I talk at lots of different events. And it's very easy for me to stand here and say, what I do is I look at lots of trends, and I look at lots of different technologies and things, and we try to join all the dots together to create a point of view. Now, when we have a look at trends, I write books. They're kind of my brain backup. These books here are about an inch thick. The technologies that I follow about 600 emerging technologies. Trends, hundreds of different technologies. So when we actually have a look at what you're up against when you're trying to plan the future of your industry, your country, or whatever it happens to be, these are the trends that impact you directly or indirectly. The future is increasingly fast-paced, it's increasingly complex, and it's increasingly complicated. And that has an impact basically on your planning, your strategy, your vision, and ultimately your point of view and what you invest in and what you don't invest in. Now, when we have a look at efficient aviation, from an operator's perspective, realistically, this is kind of the standard stack that we need. So this is high level, but we can go into details if you want to. Now, for example, increasingly these stacks, these are ICT and OT operational technology stacks. Increasingly they're automated, they're digitized, and they're smart. When we talk about smart, we have artificial intelligence at the core of the business, but increasingly at the edge of the business as well, in a variety of different places, so smart IoT. Increasingly, your businesses need to be API enabled. Now, the reason for that is if you have an API enabled, cloud-based infrastructure stack, you can connect into one service. And then as the technology changes, as your ecosystem changes, as your industry changes, you can unplug that API and plug it into a different one. So this is where we kind of talk about modular ICT. Because trying to keep up with the pace of change when you've got mainframes, basically at the back, for example, at the FAA, lots of mainframes there, I know all about those, is difficult. So you need to be able to act with agility and speed. Now, data-driven. The amount of data that your organization is going to ingest is just going to go like that. You're going to be generating more data internally, you're going to be generating more data externally from different sources, and you're going to be ingesting more data from third-party sources. If your data stack is not absolutely solid, you're going to struggle. It's got to be integrated with ecosystem partners and other industries and other parts of the supply chains and the operational stack. It's got to be predictive, increasingly, and artificial intelligence is increasingly moving us from reactive to predictive models. It's got to be reliable, but also zero trust. Now, this is where there's a little bit of a sort of maybe a dichotomy in a point of view. From a cybersecurity perspective, in my opinion, and I used to run national security at IBM, you need a zero trust stack from a cyber perspective. But increasingly, when we have a look at data, you need to consider most data as being untrustworthy. And that's going to be very difficult. And I will show you why later. The more that you trust your data, the more prone you are to cyber attacks and data spoofing in the future. It's a challenge, but I'm putting it on there simply because we'll talk about that in a bit. Now, when we actually have a look at the geopolitical situation, we have China that are developing their own technology standards. So I sit down basically with the vice minister of the minister, I sit down with the vice minister of the Ministry of Science and Technology in China fairly regularly, as well as other countries. We are seeing the Chinese developing AI technology standards, separate 5G technology standards, quantum technology standards, and so on and so forth. So what we're actually seeing is we're starting to see a global splitting of technology standards. Now, why that's important is because depending on the technology standard you adopt, it makes it more difficult for you to integrate and interoperate with different operators in different parts of the world. It also increases the cost of your tech stack. So watch out for standard splitting. Next generation ATC, we know that the FAA are doing this, and there are a lot of other places around the world. Gentle glide paths, that improves the sustainability and the efficiency, and greater traffic density. Single skies. Now, we all know basically that single skies would be a brilliant thing to have. But again, sovereignty, geopolitics kind of comes into play. But single skies would be a huge advantage for all of us. Quantum routing. I mean, every day we have about, what, 93,000 flights taking off from about 9,000 airports around the world? Routing, for whatever reason, and rerouting for whatever reason, whether it's bad weather, whether it's delays, breakages and breakdowns, and so on and so forth, is difficult enough today anyway. But quantum computers are fantastic at optimization problems. A problem that takes a supercomputer like the one that we have at the US Department of Energy, 2.5 billion years to do, will take a quantum computer seconds. They are amazingly parallel, and that's now. And these ramp over the next 3, 4, 5 years. So consider quantum routing, because it will be a game changer. Now, when we have a look at things like bird strikes, this kind of knocks the efficiency of airlines down when you've got to check the windscreens again. Now, Airbus is developing self-healing windshields, but also, thanks to a variety of different technologies, we now have things called atomic knots. And these atomic knot materials are better than Kevlar. So now we actually have new materials that can sustain bird strike impacts, and they don't bust apart an engine. So new armor composites that are much, much lighter, much thinner, and in some cases, as the Pentagon knows, you just spray them onto a building, and your building is bomb-proof. They're that good. We also have human strikes. I love flying over France. It's fantastic. Yeah, exactly. Yeah, that's it. It's the, why is my flight being cancelled? It's the French air traffic controllers again. It's like, awesome. I love them. Now, on the one hand, when we have a look at human strikes, to be fair, yeah, we live in a period of hyperinflation, et cetera, et cetera. Yeah, there are a lot of challenges, economic challenges around the world. So I fully understand human strikes. Now, on the one hand, basically a lot of the people who are striking about pay and working conditions. But increasingly, we're seeing more people actually striking because of the specter of automation. And every industry basically has a specter of automation. But automation can be beneficial, but also it can be detrimental to the workforce. So when we have a look at the use of technology, I often say, look at how technology can augment your workforce before you automate. Because when you augment your workforce, you can often get some huge productivity gains. Now, automation itself, as we know, comes in many different forms, from cargo loaders, basically, to the pulleys and everything else on the runways. And increasingly, we're seeing some airports around the world where ground operations are almost fully autonomous. And that's technology really from the transportation industry, the car industry, that is now being applied basically to ground operations at airports. When we have a look at predictive maintenance, I know that General Electric are here. They have their GE Predict system. So on the one hand, we have sensors strapped around almost every part of an aircraft, and we can predict with a decent level of accuracy that different parts are going to fail. Now, in addition to that, if we put a behavioral interface over the top of these predictive maintenance platforms, you can talk to your aircraft. And GE see this, but also so do others in the energy industry. So you could simply query your entire global fleet of aircraft or whatever it is that you're interested in, whatever assets you're interested in, and say, how's the health of the fleet? And it says, well, flight number 1, basically we're seeing increasing engine wear because the RPMs were ramped up. And the engine can come back and say, you know, I think based on my new RPMs, my expected end of life has now come down by 20,000 hours. And as an operator, you can say, well, how would I fix that? And you talk to these machines, like going to the doctor. And these engines and these big smart IoT systems can come back and say, well, maybe you need to readjust the RPMs. You say, well, how shall I do that? Well, you can do it manually, or we can just download an artificial intelligence app from the App Store, and I can do it myself automatically. So when we have a look at predictive maintenance and digital twins and so on and so forth, increasingly you can talk to your company, you can talk to your assets, you can talk to your fleets, and you can query them in natural language, and these assets can reply in natural language, which then lowers the barrier to hiring because you need less training to a degree. And then when we have a look at maintenance, increasingly organizations like Boeing are using augmented reality maintenance, which means you don't need the big paper manuals and books. You just put on some smart glasses and it says, this is the part that needs fixing. Take this out, put this widget in, do this, clip that, sign off on the blockchain, done. Plane's ready to go. Now, when we have a look at things like just-in-parts supply, this is sort of another big problem that we see. On the one hand, we have increasingly autonomous ERP-based supply chains. So by hooking in predictive maintenance, we can say, well, we think jet engine number 1 basically has got a problem, and the autonomous supply chain can automatically communicate with all the different parts of your supply chain and your suppliers and say, we need that bit at that airport by that time. But these supply chains, and the key word is autonomous, it's not necessarily automatic. They move to autonomous because they will choose the right suppliers at the right time, at the right price, and everything else, and they will optimize. Now, increasingly, we can also 3D print parts, basically actually in situ. Now, when we have a look at the enterprise-level 3D printing of aerospace-grade parts, again, General Electric, Lockheed, and others are leading the charge. And we are now starting to see more and more 3D printed parts actually being used in everything from military hardware and fighter jets through to commercial aircraft. Now, here's another thing. You probably have gigantic global supply chains moving huge amounts of things and stuff around the world, right? BMW, every BMW car that is made has 30,000 parts. BMW are now using quantum computers to optimize their supply chains, and they've improved the efficiency of their global supply chain just by changing the computing stack by 20%. Because the supply chain is an optimization problem again. So quantum supply chains, if you're not playing around with them, experimenting with them, getting a point of view on them, do so now. Because you can build these now, but you might want to start deploying them in the next 2, 3, 4 years. Now, from a customer perspective, I would love this one. I'm going to be on 7 flights this week. Depart local and fly direct. I mean, there are lots of people I speak to that just don't know they've got an airport up the road that actually does a regional hop to wherever it happens to be. Yeah. So, depart local, door-to-door routing. Now, when I'm putting together my travel itineraries, it's hell, frankly. I choose the airlines and I choose where I'm going and try to figure out the time and everything else. Then I've got to organize the transfers and figure out the layover at that airport there and how that clashes with that other part of my diary. But when we actually have a look at Singapore, for example, Singapore is increasingly doing literally door-to-door routing. So they now have a national system that all of the different carriers and partners and mobility partners like cars and buses and trains plug into. And you go onto a system and you say, I want to go from my house to that venue, and they say, this is everything you need. It's one ticket for the entire journey. So door-to-door routing, again, is possible today. I reckon I spend more time on layovers and waiting around at airports for the aircraft than I do on the actual aircraft. Now, in addition to this, we have UAM integration. So, for example, at Heathrow, they're spending £25 million because they want people to be able to move from Heathrow to the city centre within about 20 minutes. Now, UAMs, when we have a look at the cost of UAMs, it's about $250,000 per UAM. You buy them as a service. When you have a look at the cost per mile for a UAM, they're starting to get to the price of an Uber Black. Because as someone mentioned earlier, the cost of these UAMs basically is typically the batteries. But battery prices are starting to fall because we're scaling. Energy density of electric vehicle batteries is actually also increasing a lot, and we'll see that in a moment. So UAM integration, can that be your door-to-door hop? Now in France are kind of going a slightly different way. Now, when I do my intercontinental travel, I generally have to go to an airport, I wait at the airport for about 3 hours, then I travel to another airport, wait there for generally 2 to 7 hours, and then go onwards. When I go to a train station, I wait for like 15 minutes for a train. So in France, as you sort of might have seen, from May the 23rd this year, they banned short-haul flights that were less than 2.5 hours that could be replaced by train. Now, this requires infrastructure. But as I talk to different governments around the world, they start considering, well, do we actually just have an expansive high-speed rail network rather than regional flights? I mean, if you have a look at China, for example, China has built out over 4,500 miles of high-speed rail. Europe's building about 2,500 miles of high-speed rail, and America basically has something on a bit of a post-it note at the moment. But when we actually have a look at the integration of truly high-speed rail, where we're talking about trains that do 300 to 700 miles an hour, and in China, they have a T-flight concept. They have a Hyperloop concept that they want to push to 2,500 miles an hour to compete or outcompete airlines. So the T-flight is a fun one. Go and have a look at that. Invisible borders as well. Now, I love the TSA. I'm seeing them next Wednesday in Las Vegas. They're getting a little prize from me for a variety of reasons. But when we actually have a look at technology, as we see in Dubai, and Singapore the other day just announced that they're going to ban the need for passports. When we have a look at the technology that we need, you have artificial intelligence, you've got 5G, you've got cameras, and so I can walk through an airport. Why do I have to stop at security gates? It's called touchless biometrics. So as I walk through an airport, it can scan my face. It's got a facial scan. It can scan my iris from 400 meters away. And we even have the technology, thanks to SRI in Singapore, to scan your fingerprints from 100 meters away. So if you want to identify me walking through an airport or through to a gate, Why do you need my passport any longer? And then when we have a look at invisible borders as well, increasingly we see some very advanced millimeter wave sort of rapid scan technologies coming through. I mean, what is it, Schiphol, I think? Schiphol, you just dump your entire bag basically onto the system, goes through essentially an MRI scanner, and they go, that's great, thank you. Whereas Charles de Gaulle, I'll tell you what, Charles de Gaulle had people stripping naked basically to put them through the scanners basically yesterday. That was nuts. So there's a lot of different things that we can do basically to make borders actually invisible. Now, when we look at safe aviation, biometrics for safety. This is a tricorder. If you've got a lot of people around, for example, an airport, we can use cameras, for example, with ground crews, to identify that they're getting tired. Then you can connect that to your workforce optimization system. So when you see that Brian, the baggage handler, is getting tired, you can automatically swap him out. It improves productivity, improves mental health. But you can also read their pulse. You can also read their heart rates and everything else just from a standard camera. When they're talking, AI plus a microphone, you can understand if they're upset, depressed. So there's a lot of different things that you can use surveillance like biometrics for to improve the safety of your workforce. One of the other challenges you have, getting real-time information. You don't really have a problem getting information. You have a problem getting real-time information that you're able to analyze at speed. With Airbus and the US military, so about 2 years ago, Airbus at Charles de Gaulle again trialed basically the first fully autonomous A320neo. You know, you can sort of probably see the video online where, you know, the pilots are sitting in the seat, and they've got their hands off the controls, and they're looking at each other like little children laughing as the plane takes off. Now, when we have a look at full automation, that's going to be down the line because the regulators have to get their heads around that, and there's got to be lots of tests and everything else. But the US military, essentially DARPA, have been putting artificial intelligence into U-2 surveillance planes. And what they found out was the AI gathers data via sensors and is incredibly good and incredibly fast at analyzing all of the sensor data coming into the aircraft and then giving the pilots rapid information to say, I've seen this over here, I think you should do something about it. So this is why I talk about AI as a co-pilot, not as the actual pilot, to augment the pilots. When we have a look at counterfeit parts, we're seeing huge numbers of counterfeit parts coming out of Russia at the moment with obviously the sanctions and things. But on the one hand, counterfeit parts are easy to make. But secondly, we can use biological tags. We can use crypto anchors. And we can even use nano tags basically to identify that a part that we have in the shop that's going on to the 777 is genuine. So when we actually have a look at the traceability, you combine this with Web3 and blockchain technology and you have transparent supply chains. But in terms of identifying counterfeit parts themselves, there are a lot of new sensor and tag technologies. Now, one thing that we have is you all start, as we've heard throughout this conference, more data, and the answer to lots of problems is machine learning and AI, right? Now, one of the problems that you're going to have is as you start using artificial intelligence more within your essentially mission-critical businesses, because you're moving people around at 40,000 feet, is at the moment, if something goes wrong or you want to query an artificial intelligence, you can't. It's not very good. But the more that you bake artificial intelligence into your enterprises, we've already seen AIs from Google, Baidu, Meta, and OpenAI talk to each other in different languages that they invented, and then encrypt communications. So now imagine that you want to understand why your AI did something in your air traffic control system, but you have no idea, you can't ask it. So you do need to be thinking about how do you build explainable artificial intelligence basically within your AI enterprises. Now, this was part of a study into how you can hack different manufacturing technologies. Now, we have 3D printed parts, but we're moving to 4D printed parts. 4D printed parts are parts basically that change shape. So, for example, you can have an aeroplane wing that when it gets to 20,000 feet and there's a particular level of oxygen, the aircraft wing changes shape to become maybe more aerodynamic or whatever it happens to be. But if a hacker changes the CAD file for a 4D printed part, like a rotor in an engine, like a turbo fan, what they found is they can actually get the turbo fans to change shape at altitude. And you can induce a serious, catastrophic failure in a jet engine. So when we talk about new manufacturing technologies and new risks, you're not using 4D printed components right now, but at some point you might. And these are the new unknown risks. As Kyle Ellis, basically from NASA, was saying, there are the unknowns. These are the unknowns that we try to surface. Now, when we look at cyber, my suggestion here is that as businesses, you separate your cyber operations, your security operations, from your safety operations. They are very close cousins, but they are not the same. Cybersecurity and physical security is not really the same as safety. Therefore, they require two different teams, in my opinion, because they require different skill sets, but those teams obviously need to talk to one another. When we talk about trusting data, I said really try to get to the point where you have zero trust in data, which is difficult. We're seeing more satellite and GPS jamming. We're seeing more GPS interference around the planet. It's easier now to hack satellites. We reprogrammed a satellite in orbit at a Las Vegas conference about 2 months ago. It was a first, and it was sponsored by the US military again. Data spoofing. We're now using GPS, we're now using deepfakes to create deepfaked, fake GIS data. So all we need to do is start tweaking and modifying the information that's coming into your systems, whether it's to a pilot, whether it's to air traffic control, or whatever it happens to be. And if we start changing just a little bit of data, it can have a massive impact on your operations and safety. Poisoned AI. You all think it's great. Let's go and put artificial intelligence basically into our enterprises. So what you do is you go out, you find a couple of sources of AI, you train those AIs on data that's relevant to you and your industry and the things you care about, and then you use those models in your business. However, hackers know that if you want to train an artificial intelligence, you're probably going to use this aviation data set, because it's open source, and they can poison it. So when you train your model and you bring your model in-house, little do you know, they have a complete back door into all of your systems. So how do you vet the artificial intelligences that you're bringing in-house? Do you audit them? Do you do A/B testing? Hackers are already doing this. States are already doing this. Quantum safe. We've seen an increase in the number of attacks and cyber attacks against the aviation industry. It's kind of high value. So now we're starting to see different geographies actually moving essentially their ATC systems basically to quantum safe. Because quantum computers will be able to hack your encryption. If you're running 4096-bit encryption, we can crack that in about 8 hours. If you're running 256-bit encryption on your systems, we can crack that in a few minutes. So what happens when we start putting a quantum computer against your infrastructure, your software, your systems? It's not going to stand up for very long. And then, as we've discussed, from a cyber perspective, as well as an airline perspective, I think you should have vulnerability disclosure programs. Because sharing is caring, right? You should have bug bounties. You should have hackathons. You should do cyber war games. Because increasingly you're using AI, data, automation, and this stuff is all connected. In different ways, obviously. How many of you do cyber wargaming? How many of you try to hack your own systems? How many of you do red teaming? And then as for sustainable aviation, there's actually quite a lot of good news on here. Now, we keep talking about sustainable aviation fuels. Now, we can use genetic engineering to create even more energy-dense aviation fuels from algae, from kelp, believe it or not, even from bacteria. But when we have a look at the other technologies that are coming through, we've got blue and green hydrogen coming through. So in the Middle East, as well as in the UK, we're spending billions trying to develop green hydrogen plants. We've got biogas, but we've also got renewables, and we've also got lithium-ion batteries. Now, if you 3D print a lithium-ion battery, you can print it with 400% more energy density than the batteries you have in your electric vehicles. Now, for aircraft are a little bit special because you need a boost. You know, when you're taking off, the lithium-ion batteries need that boost, and then they cruise. Cruising on a current lithium battery is fine, but it's the boost that's the problem. MIT have solved the boost problem. But when we actually have a look at lithium-ion batteries, you can 3D print them. We can do all kinds of different things. If you put graphene into a lithium-ion battery, it charges 500% faster, thanks to Samsung. And then we've even got mini nuclear reactors coming through, courtesy of companies like Rolls-Royce. Maybe one day they go in a plane. Then we have companies like Airbus. With the A320neo, they kicked off their generative artificial intelligence design program because if we have a partition like this, AI is getting increasingly good at designing parts. So you say, design a partition wall that's 98% lighter, but just as stiff and durable. So AI is already being used to take up to 98% of the weight out of aircraft components, as well as in the automotive industry. Ford, for example, are using generative artificial intelligence to take 50 kilograms out of every car. So when we talk about sustainability, we use this to reduce weight. We've got smart digital twins. You can analyze and model anything all the time to figure out what's the best for you. Then we've got the General Electric, the GE9X. This engine used to have 300 components. So think of that from a supply chain perspective. 300 components that can fail that you've got to stock and figure out what to do with. This is 3D printed. But again, using generative AI, we've done something called flattening the supply chain. It has 7 parts. Easier to operate, easier to maintain, and if something goes wrong, you can technically, if you've got something at an airport, 3D print the parts. Easier inventory management, lower capital expenditure. So this is how we simplify stuff. And then the last one, AI is also getting increasingly good at designing new materials and new alloys. So most of the aircraft that you fly are made out of either 7,000 or 9,000 aluminum alloys. Artificial intelligence has now designed alloys that are exactly the same tensile strength, same durability, but half the weight. Or the same weight, but double the strength. So when we start using artificial intelligence to design new composites, new materials, new alloys, we take even more weight out of a plane, which makes it more sustainable. And that's it. That's it. I'm now out of energy myself, so thank you very much for listening. I hope you enjoyed it.
That's brilliant, Matt. Brilliant. To get you a beer. I feel like I've just had a simulator session. I need to go and sit in a dark room and process everything that's just gone on. Excellent, Matt. Thank you very much for your insights there.